Hello and welcome back to another episode of the increasingly difficult TIS-100. So, sequence reverser, signal multiplier. Read the values from in.A and in.B. So, multiply the values and write the output. Now, just in case anybody wants to know, I did go back to the manual and did look for the multiply instruction, and it's probably on a missing page or not existing. So we don't have a multiply, which I presume is the point. So I presume we've got to add them instead. Right. Okay, so what are we going to do? Well, I'm going to start from the bottom. I'm going to work my way back up. So this bottom box is going to have a little job. And its job, what I'm planning on doing is get this one to add a stream of numbers together. And get this one then to take in to generate a stream of numbers. So basically, instead of multiplying, which obviously we can't do, I'm going to have two numbers. So I'm going to add one of them together, the other one number of times. And instead of doing the adding in the same box, what I'm going to do is I'm just going to send them down. So this is going to produce a stream of numbers coming down here that this box needs to add. So how would I add a stream of numbers? Well, let's have a look. So the first thing I need to do is I'm going to need to have some sort of start where I'm going to move 0 to the accumulator to the register. And that's going to be like my running total. Now I need to save that in some way. And I could swap it into the backup, but then I can't add it. So what I think I'm going to do is for the main loop, I'm going to move it to the right. So I'm going to use this box here as a kind of backup storage, just one item. Now, possibly using the stack for this might be better, might not, I'm not quite sure. But I'm going to try it this way and see what happens. So then I'm going to move up to the accumulator. So my accumulator here normally stores the current running total, but when I need to process this one, it's off to the right. So basically here I'm going to move left, left. So basically just send it straight back to it. Okay, move up to the accumulator. Now I need to check. Now I'm also, when I say add a stream of numbers together, so like let's say we'll pick, I don't know, 6 5s. So let's say I decide to send the 5 down 6 times. Now obviously it would be more efficient to send the 6 down 5 times, so maybe we'll address that at the end. But it'll get 5 5 5 5 5 5 6 times, and then we need somewhere saying no, stop. So again, we're going to use the concept of a 0 for that. We could use any strange number. The list doesn't appear to have negative numbers or any number that's really higher than 10, so I'm sure we could, but let's use 0. So this adds a stream of numbers together until it sees a 0, at which case it outputs the total, resets the, its internal count, and starts again. So move up to the accumulator, jump on equal to 0, end. Yes, I know it's an undefined label, and there's end there. So this is what happens when we see the end of the loop. Otherwise, so what do I have? I have the old total out here. I have the new value here. So if I add right, I now have them added together. They're in the accumulator. I think I should just need to jump to the L, to the start of the loop. What do we do if we get to the end? We're just sending out the number, and the current number was over here. So I believe all I need to do is move right down. And then this loop will naturally fall back to the start. Remember, there's a kind of an implicit jump back to the start on each of these boxes, which will then reset the count and start again. Okay. So this box here has to generate that list of numbers. So what I'm going to do is, let's say the top The one we get in from here will be the iterator, the number of times we do it. And the one I get in from here will be the adder, the thing we're going to add that number of times. So, move up to the accumulator. So this is the loop part of it. So what do I need to do? So this, in effect, when I get to this loop here, the accumulator has the number of, what's the word I'm looking for? The number of times I still need to go. So I will then move up to the accumulator. Say I save that. And say I move left to the accumulator. Okay. So it's just going to be a matter of just keeping in my head where the various things are in the accumulator and the backup, isn't it? Okay, so if I was to swap them. Now remember, swap not only brings the value from the backup back to the accumulator, it also sticks the accumulator into the backup as well. So it is a genuine swap, whereas save is just a one-way operation. So at this stage, if my head is right, I should have in the accumulator the value up here, which I said let's just treat as the one that decrements, and in the backup the thing I need to be adding each time. So here, if it's 0, jump to the end. So it's either excuse me, it's either 0 at the start or it's going to be 0 after I've decremented it. So it's not 0. So where my cursor is flashing now, I know that I still have more time to move. So if I swap, I now have the actual value that I want, the actual value I'm adding. If I move that to down, move accumulator to down, if I swap again, I feel I'm doing too many swaps here, but subtract 1 and jump to loop. So, if that makes any sense to anybody, what's happening in this box, what I'm trying to do in this box, excuse me, must I have a drink of coffee? Oh, excuse me. What I'm trying to do in this box is I have two values always in the accumulator and the backup. One is the count, the number of times I'm going to do it. The other one is the addee or the adder or whatever we want to call it, the thing that's going to get added that number of times. And I'm going to send that down there. When we get to the end, I need 2. So when I get to here, jump equal to 0, that's the count down. So I don't need to send anything down. So I need to move 0 to down. And that should be it, shouldn't it? What else do I need to do? We've decremented this already to 0. I've just checked it. What's in the other one is irrelevant because we're going to blow it away. So that may well work. Right. So this one here. So again, to be efficient, and because also the fact we're going to be using zeros, what I would like is, remember, we have two numbers here. When we're doing multiplication by addition, we have to add one of them together the other one number of times. Now, it makes far more sense because like it's the same amount of operations time to add a 5 to a 5 as it is to add a 1 to a 1. Therefore, it makes sense if we look over here, in all these cases, to always use the smaller number, including if it is 0, because it does want to multiply by 0, as the iterator, as the number of times we're going to run the loop, and use the larger one as the one we're going to be adding together. So with that in mind, we need a little trick up here, not a trick, we need a little mini program to swap them around. So move up to the accumulator, save it, subtract left. Okay, so if we get, let's just think about this. If we subtract left from this one and we get a number that's less than 0, jump less than 0, what did that mean? That meant that the one on the left was bigger because when we subtracted it from this one, it went negative. So that means that the one in B is smaller. So call that B small. Okay, that didn't make any sense at all, did it? So let me just, it can be, what am I doing? Okay, let me repeat that again, just some, not for you, everybody out there understands that perfectly. It's my brain I'm trying to fix. Okay, if we have two numbers, there's one over here and one here, I subtract this one from this one. If I get a negative answer, that meant this one was bigger than this one because when I subtracted it, it went less than 0. So this one is bigger, therefore this one is smaller. Yes, that makes sense. Fine. So we've B is smaller. I want to send it down here as the iterator. So swap, move accumulator down. Now I'm also going to have to give this one back a number as well. So let's say this one's centered again, move left, left, jump, start, something like that. So this is, so we check this. So this is the opposite. This is if A is smaller. So if A is smaller, what I want to do is move is swap, then move. And do I want to move left down? See, this is where my head can't quite figure out all this stuff. Move left down, which way it's going to block. Move left down and move accumulator left. And then we don't want to fall into B small. We want to jump to the start again. Right, so again, not following all that. What this is trying to do is of these two values, figure out which is the smallest one, send the smallest one down here and the bigger one back to here. So for this to work, we need to move up to the accumulator. We then to move the accumulator to the right, move it again, and then we're going to get an answer back here. We're going to get one here. If we didn't get itself back in effect, or this one's back, move, not mock, move right down. And this one has just got to move no, actually, it doesn't need to be that way. I don't need to come via this one. I could send them both down here, couldn't I? I could always send like I could always send down the smaller one first. And that would use less nodes, wouldn't it? Let's try that. So, what I'm going to do is, instead of taking one from here, I'm going to send both of them down this way. So, they're both moving up to the accumulator. But the first one down is going to be, I need to send the smaller one down first. So, this is if B is smaller, so I send that down. So then send left, down, send left down, send accumulator down. Right, so this shouldn't mention left anymore. Oh, dare I press it? Oh, yes. That's looking good. Probably, now is it doing it right? Is it, I'm just going to stop it and step through it. So when we're here, what I want to see, like the first one is a 1 and an 8. And the 1 is here. So I want to see a 1 and a 4 come down. And then I want to see Oh, I think I just was reading the manual again, and I think I can put an exclamation mark here. And that's a breakpoint. I don't know if any people have used debuggers in their real life, but a breakpoint means that I can press run on the program and it'll stop every time it gets to this line of code. So step. Oh, that's not that useful, is it? If I hit run again, so it gets to it, but it's not when it actually gets a value. Let me hit run. Yes, I've entirely missed the 8s, haven't I? But here, for this one, I'm dealing with the 1 and the 4. And it's definitely sent the 1 down first. Okay. Okay, let me just stop that. That's not working quite as I was hoping it to, but I saw it in the manual. It seems to be doing it when the line, but that line is going to now block for any length. I should, yeah, haha. You see, I'm an idiot. Instead of blocking on this line, why not put a... So, step. It sends the 1 down to the 1 and the 8. Brilliant. Run it again. And step. It sends the 4 down. From the 8 and the 4. Okay, I am not understanding this at all. There's no point delaying this video unnecessarily whilst I scratch my head and act like an idiot. So, what was going wrong there? I'm not quite sure. But anyway, it looks like it is working. I'm not sure whether I could do it without using this box here. See, in this one, I do manage to use the backup and the accumulator and swap between them quite well. But I'm not sure I can do that here because I need to add, in effect, I need to add one to the other. And there's no command like that says add backup to the accumulator. If that command existed, brilliant. But it doesn't. So I think I do need to, instead of using the backup in this one, use another one. I'm not quite sure what I could be using these stack memory nodes for. I mean, maybe there is a way of simplifying this if I do use them. There probably is. Interesting how idle this one is. You know, in my head, this was doing an awful lot of the work, but it's... Oh no, it is. Actually, this is, sorry, that's me completely misreading this. Idle fight. So this is doing all the work. This is doing much less. This is doing much less. This is doing a lot of work too. So these two are running nearly, oops, all the time. And there we go. Signal multiplier test passed. Signal, so 1100. God knows if that's particularly good. No, count 5. Okay, so it is possible to not use it. I presume, yeah, maybe if you continue editing this segment. Yeah, you have to use that one. You have to use that one. Okay, so there must be some way of doing it without using this one, otherwise you couldn't, because I mean, you have to use that one and that one. There's no option. If you don't put value code in these two, nothing's going to happen, and there's no magic way of teleporting values down. So you have to use at least one in this row here. You have to use this one. So if you can do it with 4, it is possible to do it without using that one. That's interesting. I wonder if these, do they count as node used? Because I mean, you obviously don't stick code in these. They're just a stack. So maybe they do show up as used. I didn't check the other one whether they show up as used if you stick a value in and then pull it back out again. Anyway, that was Signal Multiplier. Thank you very much for watching. If you enjoyed it, please drop a like on the video. I'm still playing Infinity Factory. I'm still playing this, probably playing lots of other games in the future. If you'd like to subscribe to the channel, that would be great. Any comments on how terrible this was done, or whether there's anything I could be doing much differently, I'd really like to read them. Thank you again for watching. Bye now.